Hello everyone, and in this video we are going to be walking through how does encryption work when we want to make sure that a message from person A to person B is something that only these two people can understand when you don't want someone else to be eavesdropping on you, for instance. And so we're going to be talking about encryption, specifically asymmetric encryption, in which it's okay if someone else intercepts a message that is meant to go from person A to person B, but only person B can actually decrypt that message. So in this story, we're going to have two people, Alice and Bob, and Alice is going to want to send some kind of message to Bob, and Alice doesn't want anyone else to be able to understand what her message is to Bob. So basically this is privacy and how we ensure it on the internet. So in asymmetric encryption, it all starts with having a public key and a private key. And so if Bob was to want to partake in this, the first thing he's going to do is he's going to create a public key, and I'll call this public key B, and he'll also create a private key, which I'll call private key B. And so the important thing to note about private key B is that only Bob will ever know it. And that's how things are supposed to work here. And the reason why only Bob should know this is because the private key is how he will decrypt stuff. And so public key B, Bob's public key, can go wherever. It's okay if you know it and his mom knows it and everybody else, totally fine. And so what is going to happen in this instance where Alice wants to send Bob an encrypted message, she's going to give, or Bob's going to give Alice his public key. And it's okay that everyone else knows what the public key is. And so what Alice is going to do with this public key B is she's going to make use of this thing called the RSA algorithm. And there's many other algorithms out there like AES, but we'll stick with RSA for this one. And for our purposes, just think of it as a black box. And the input to this box is going to be the public key B that Bob gave. So public key B, and I should probably pull this out a bit so that the arrow looks better. And so we've got Bob's public key going into the RSA algorithm. And in addition to that, Alice is going to want to actually say something to Bob. So we're going to have some text. And so I'm going to do that. And we're going to put in this text like ABC or something. And so the output of a public key and some text or some file or whatever to the RSA algorithm is going to be ciphertext. So I'm just going to have an arrow right here, and the output of this is ciphertext. And the whole point of ciphertext is that anyone can read it, just like anyone could read Bob's public key, but unless you have the private key, Bob's private key, you cannot decrypt this ciphertext. So it's just a bunch of gibberish, and we'll walk through a real story on this computer where you guys can see what the actual ciphertext looks like. But the whole point here is that when you take that ciphertext and you pass it, and you pass it as an input into the RSA algorithm again, and you also pass in an input of the private key B, the output here is going to be whatever that original message was. In our case, it's just that string ABC. So that is the theory. So in terms of how this communication would occur between Alice and Bob, basically this ciphertext component right here is what's going to pass over the network. So this is all that ciphertext. And it's totally okay that other people on the network are able to see the ciphertext, because without that private key, they're not going to be able to read it. So this is the story. Now, to actually do this on our computer, so we have a little bit of an interactive session here, I'm going to open up Terminal right here. I'm going to clear my screen. I'm going to make a directory, and we'll call this, encryption or something. We'll call it encrypt. And I'm going to change directory into that encrypt folder that I just made. And I'm going to ls, and we're going to see that right now it is empty. So if you're on Mac, there is a program called OpenSSL. And so the very first thing I am running here is basically this thing that's going to generate a private key pair with that RSA algorithm. So I'm Bob in this story. So I've just made a private key. This is Bob's private key. And if I run ls inside of my directory, you can see now that I have this private key.pem file. So the next thing I'm going to do is I'm going to run this other command, and it's going to generate a public key from my private key. And in this case, in following our story, this would be Bob's public key. But basically, if I ls again, you can see that this public key.pem is something that I would share with anybody. The entire network would know it. So if I cat and public key pem, you can see what the public key file looks like. And that's totally okay. And then you can also cat your private key, although that's something very sensitive. And obviously, if this was a real thing, you would never want anyone to know what your private key was, because if they did know, then they could decrypt all of your private messages. And so basically, now that we've created a public and a private key pair, I'm going to share that public key file with Alice. And then now, pretending to be Alice, I'm going to make some kind of message. So I'm going to run nano, and we'll call this plaintext.txt. And in this message, I'll say, hello, Bob, exclamation point. And then because this is nano, you press Control O to write out to save it. I'm going to hit enter, and I'm going to press Control X to exit. And then I'm going to cat, roll ls, we will cat the plaintext. So you can see the message inside of this file that we just created. And again, this is something sensitive that Alice only wants Bob to be able to see. So what Alice is going to do now is that on her computer, she's going to run this command. And so basically what's going to happen here is it's going to use the OpenSSL service, and I'm going to be using that public key, that Bob's public key PEM file, in order to encrypt the file inside of this directory called plaintext.txt. So when I run this and I run ls again, you can now see that we have another thing in our directory called encryptedmessage.pem. So if I run cat encryptedmessage.pem, you can see that it's just a bunch of complete gibberish that would mean absolutely nothing to anyone looking at it. So this is that ciphertext right here that would actually be transmitted over our network. And now, so now I'm pretending to be Bob again. I'm going to receive this file, this encrypted binary file. Doesn't matter what the file type is. But basically, if I run this command, sorry, give me 1 second. If I run this command, I'm going to be using that OpenSSL service again, and we're going to be using my private key file in order to decrypt it. So if I run ls one final time, you can now see that I have a decrypted message.txt. So if I run cat and then decrypted message.txt to see the contents of this file, you can now see that it says hello, Bob. So I got that message from Alice that was originally plain text, then we encrypted it to ciphertext that no one else could understand, and then because I had my private key, I was able to decrypt it and understand the original message, and no one else other than Alice knows what she said to me. So that is the story and a little example as to how we're able to have secure communications using our encryption, and specifically that asymmetric encryption. So I hope this is helpful stuff. Thanks all for watching. Let me know if you have any questions, and be well.